Good afternoon, everyone. Welcome. So as we wait for a couple more people to enter from the waiting room, I just want to welcome you all to People for Peat's third regional symposium, which is excitingly called Tech on Peat. So thank you so much for being here today. We'll just let a couple more people trickle in, and our speakers are all here as well, ready to go. So thank you for joining us. All right, so I think that's most people for now. I'm sure people will trickle in as they finish their lunch if they're in the ASEAN region. So again, thank you so much for joining us. My name is Mariam Ghani, and I am the Stakeholder Engagement and Communications Manager at Tropical Rainforest Conservation and Research Center, also known as TRCRC. And we are an environmental NGO, and we are based in Kuala Lumpur, Malaysia. And we're also part of this larger coalition, as you've probably heard the name People for Peat. Having joined our symposiums before, we're part of this larger coalition. So let me just go over some housekeeping guidelines for today's symposium. It's going to be a really exciting day. But before we start, please try to rename yourself in Zoom to the following format. So making sure you have your name as well as your organization. So for example, for myself, it is Mariam Ghani and TRCRC. And throughout the presentations, if you could keep your microphone off and muted, that would be great, as well as your video so that it doesn't take up too much bandwidth. And then for the chat box, we have, of course, room for you to ask all the questions you like. So you can ask those in the chat box. And we'll also, of course, have a Q&A as we normally do. So before we get started, I just wanted to get a sense of where everyone is coming from. So let me launch a quick poll for that. So, okay, 1 second. That's correct. Oops, I'm just asking you where you're from first. That's no worries. So I'll just give people a couple seconds to answer the question. All right. So we have people joining us from Indonesia, about 50% of you. And then Malaysia, 38%. Thailand, welcome, Sawadika, and others. So I'm guessing people maybe from Europe or the UK. But either way, thank you so much for joining us. And we look forward to a really interesting discussion. Okay. So just quickly for our agenda today, we have, of course, the introduction, and that's by me. And then we'll have some really, really interesting presentations by Professor Chris Evans and Dr. Une Hovani, followed by Professor Engineer Dr. Aduwati Sali. And all of these are going to be talking about how technology has been used to further conservation and further peatland protection. So really, really exciting topics for today. So I'm sure you guys will have lots of questions. And then, of course, we have a Q&A after. So let me just jump right into it. We have our introduction. So I'm going to play you a quick little video about People for Peat.
Prevention activities with the real action in the ground, together with the local peoples and supported by government and the corporation, and it will be one of the best solutions.
My hope for the Asian peatlands is that there will be more awareness amongst the general public, amongst the government, amongst the private parties about the very important role peatlands play in regulating the climate, in maintaining biodiversity, and in providing an income for local and regional communities.
So to maintain peatland ecosystem, it is essential to build capacity of local communities, especially in restoration and wise use of peat forest.
In the future, we hope to see more businesses on peatlands to operate sustainably. let's help protect our peat forest together, because we need to set better future for our children.
All right. So just a bit of an introduction about People for Peat and how it's placed in the larger scheme of things. We are part of a two-component coalition. So there's component one, which is working with with state actors, and we are part of component two, where we work with non-state actors specifically. And our projects are both funded by the European Union, and our project timeframe is 3 years, and we're currently in our final year. And overall, both of our goals here in component one and two is to reduce fires and haze in the ASEAN region. So we're doing that by mainstreaming data that hasn't been publicly available, or it's just very different in different countries. So we're trying to compile all of that and make it available to as many people as possible. We were working on businesses, sustainable businesses and capacity building, as well as outreach and advocacy, which is kind of like what we're doing today, to share with the public about peatlands, what people around the world are doing to conserve them. So our coalition consists of 3 organizations. Obviously, I'm from Tropical Rainforest Conservation and Research Center, but we are also joined by some really cool partners. We have WRI Indonesia, which is World Resources Indonesia, where they run a research organization that turns ideas into action, a lot to do with the environment, economic opportunity, and well-being. And we also have the Sustainable Trade Initiative, also based in Indonesia, who bring governments, companies, NGOs all together so that they can move forward global sustainability, especially in terms of livelihoods. And then, of course, we have TRCRC, and we typically work with rainforest restoration throughout Malaysia and now throughout ASEAN. So these are some of the challenges that we're trying to address with our coalition. So as I mentioned before, there is this widespread lack of reliable data and information out there about peatlands, especially in the ASEAN region. We contain a really significant amount. I think 56% of the world's tropical peatlands are located in our region of Southeast Asia, yet it's not, a lot of the data is not accessible, or there isn't a set definition on the word for peat. So that's a challenge that we're trying to address with providing research grants for more people to do research and making sure that it's available on things like our website and other areas as well. And then we have the business hub, which is what we're trying to do, is noticing, there's really limited options for sustainable businesses on peatlands, and people don't really, go into peatland degradation for fun or because they want to. It's because there is no other option. And we're here to show that there are some other options for businesses that are going to work on it without degrading. And also we're trying to provide and connect, invest to these sustainable businesses so that we show that there is economic opportunity without, again, degrading peatlands. And then lastly, we're trying to address the lack of awareness and capacity on peatlands as well. So these are some of our actions. We've done like research webinars, as well as research proposals, trying to determine, what apps in the data information. And then for pillar 2, we have been working really closely with a bunch of different, what we call cohort members, who are currently working on sustainable businesses on peatlands and putting them through an accelerator program. And they'll be presenting their projects really soon for investments. That's very exciting. And then for pillar 3, we've also been doing a lot of different awareness activities, including this symposium. And also we have been running a Peat Ranger program in all of the different countries that we're currently working in. And that is to build capacity within the local community so that they are better equipped to protect their own peatlands. So this is just an overview of some of the different activities that we've been doing. So despite the COVID pandemic, we've been able to still engage with a lot of different people, people like you today who have come and attended our symposium. So we're very, very grateful for your engagement. Okay, so I asked this question earlier already, but let me ask you a different question, which is, how did you hear about our symposium? It's always good to see where people are coming from, which one of our channels is most effective. So do let us know how you found out about today's symposium. Oh, I have to. There we go. Sorry, apologies, just have to relaunch the poll, but you can answer now. So was it through WhatsApp? Was it through our emails, your friends, or through our social media platform? So far, it seems like a lot of you are coming through social media. So good job, team. We have a lot of engagement through our social media, which is great, which is really something we relied on, especially during the pandemic. So let me just share that with you all. So yeah, Q, thank you for joining us today. Okay. So next, I get to introduce, I have the pleasure of introducing our upcoming speakers. Just give me a second here. Sorry, just having a bit of technical issue right now. 1 second. Okay. All right. So I'm really excited to introduce our first speaker for the day. This is none other than Professor Chris Evans, who is a biogeochemist, and he has 25 years of research experience in both upland and peatland biogeochemistry, soil and water carbon and nitrogen cycling, greenhouse gases, water quality, process modeling, long-term and large-scale data analysis. And he's also led projects for English and Welsh governments, as well as other public and private institutions. He has provided science-based evidence and policy advice to a wide range of government, NGO, private sector organizations, which includes the Department of Environment, Food and Rural Affairs, Department of Business, the IUCN Peatland program, as well as the water industry and various different NGOs, such as ourselves. So he currently leads several research projects on peatland management for greenhouse gas removal, and he's published over 180 journal articles, which have been cited over 16,000 times. So we're very, very lucky to have him here today. And he's also a lead author of 2 PCC reports, the 2014 Wetland Supplement and the 2019 Inventory Refinement. So that's our first speaker, Chris Evans, which of course is quite a familiar name to a lot of people, but we get to hear from him very shortly. And okay. And then next up, we have Professor or Dr. Hone Hovani. And Dr. Hone is, 1 second. Dr. Hone is a forest engineer, and he has over 12 years of experience working in rural development in developing countries and academia. His research focuses on peatlands, biogeochemistry, and the implications of peatland land use conversions on the carbon balance, greenhouse gas emissions, and water chemistry. And Dr. Hovani has a particular interest in low-cost sensors and how to apply this affordable technology to peatland research, especially in tropical peatlands in Southeast Asia and in VET Central in Africa. So he's currently leading the development, manufacturing, and implementation of peat cameras to monitor peat motion and other environmental variables in the UK through collaboration with external partners, also across a range of different peatland systems and land uses in Europe and Southeast Asia. So we have both of these speakers today, which is really exciting, and they'll both be talking about the technology on peat to monitor subsidence. So without further ado, I will introduce Professor Chris Evans.
Thank you very much. I'm hoping that Honai will share the presentation he is doing. Brilliant. So yeah, good morning or good afternoon, everybody. So yeah, the first thing I should say is I got home from Indonesia. I was in Riau. I got home on Saturday, so I'm a little bit tired, but I will do my best. And Honai has very kindly prepared this joint presentation while I've been traveling. So I'm not super prepared, but I will do my best. So yeah, I'm going to talk about or I will introduce the work that Honai has been doing really on our monitoring of peatlands using, which is it's low tech on peat. I think it is really, which is what we're aiming for actually, because, well, I'll talk about why. But just to first, well, let's go with the introduction. So, well, you can see this. So I think you will know much of this, but I will just repeat some of it. That, as you know, global exploitation of peatlands for agriculture, fibre production and other uses has contributed significantly to global greenhouse gas emissions. The two major regions where that is occurring are in Europe and in Southeast Asia. I started out, of course, working in Europe, particularly our agricultural peatlands in the UK, which are not exactly the same as Southeast Asian peatlands, but they do have some similarities. There's deep drainage, there's very intensive land management in some areas. There's just essentially degradation in others. We measured the emissions, they were very high, and we're working with farmers and with governments and with other entities to try to mitigate those emissions. As following the work I've been doing here, I've been working out in parts of Southeast Asia for about 15 years, maybe, over 10 anyway, and realizing that some of the challenges are the same, but some of the challenges are very different. And the things that are different are firstly just how many people are living off the land. And secondly, that some of the sort of what seem simple solutions here are really not practical in Southeast Asia, and that's to do with the spatial scale, the availability of technology to support that. We can't put, that's a picture of a very expensive flux tower on this slide. We can't put those everywhere. They're $100,000 each just for the sensors. Plus that's on a tower there that cost another couple of $100,000 at least to build. So it's a very expensive thing to do. So really, that's why we're interested in using lower cost sensors to try to sort of solve some of the challenges and help people in the region and elsewhere to monitor and verify change. So if we go to the next slide.
Yeah, all right.
Well, as that one says, satellite monitoring of greenhouse gas emissions isn't possible. Sadly, we can't just put a sensor over them and monitor that. So we've been looking for options that would allow, and other people have too, to measure things about tropical peatlands that would allow us to determine what's happening to them, what condition they're in, and therefore what their greenhouse gas emissions might be, both of carbon dioxide and of methane. And if we know that, then we can measure change. So where there's a restoration or where people put in place mitigation measures, we can demonstrate that that's delivered a benefit. So in 2018, the UK Space Agency funded a project called PASSES, which stands for Peatland Assessment in Southeast Asia by Satellite. The project had a kind of mix of a kind of technological development, sort of business aspect, but was also intended to support sort of development needs within the region and to work with local stakeholders to provide tools that would be useful to them. And the aim of the project was to develop the potential for combining a methodology called INSAR with traditional Earth observation processing. So I think there'll be a slide explaining what these are, but as you can see on this slide, it's basically a method that's using radar. Perhaps go back one, Honai, actually.
Yeah, sorry, yeah.
Yeah, thanks. So the Sentinel-1 satellite, which is a European satellite, it generates freely available data. It's basically firing radar pings at the ground every few tens of meters, and measuring the bounce back. And that's partly used for things like soil moisture monitoring. But if you have a series of these measurements, you can look at how much the bounce back time deviates between sequential measurements, and get what's called an interferogram. And I'm not going to try to explain it properly because it's not my expertise, but this is used to measure changes in ground surface elevation, and it works very well in areas like mining, where there's been land subsidence, and after earthquakes you can see the effects of the earthquake on the ground. And the challenge here is to try to use it in forested or vegetated peatland ecosystems. And the method we're using is an adaptation of this by a group at the University of Nottingham, which tries to measure the coherent signal within noisy data. I think that's the simplest way to say. So it's measuring the number of pings that actually get through to the ground surface. So I think it's quite challenging. I don't think this method necessarily will work everywhere. I think in dense forest it's very challenging. But in some circumstances it seems to be working quite well. For example, the visuals here show the development of an oil palm plantation in central Kalimantan. And you can see those red blobs, and that's showing that as the forest was cleared, or the land was cleared, I think it was already deforested, and drained, there was subsidence of the land. So in this case, it was useful for identifying a hotspot of peat elevation change and probably emissions resulting from that. So what we would like to do, as it says here, is to provide a robust monitoring tool that could be used by whether it's the Indonesian government or other regional governments, or companies or NGOs or anybody else, to try to measure what's going on, verify the benefits of conservation and restoration, and hopefully support responsible peatland management within the region. That's the ultimate aim. But to do that, we need to know what's actually going on the ground. And so while the group in Nottingham were doing the work with the satellite data, my group in CEH was tasked with ground truthing those observations. So we were thinking about, how do we do this? How do we measure elevation change in these quite remote areas? So we needed low cost systems, but we also needed reasonably high resolution. So we started out using subsidence poles, but we've moved on a little bit from that. And I think Honai will explain what we're doing with that.
Yeah.
But this is where we would like to get to, I think. And we've got a number of projects ongoing related to both Southeast Asia and to the UK and elsewhere, actually, trying to develop this approach. So the idea is that if we can measure changes in surface motion from the air, these are very tightly linked to the condition of the peat. As the peat is drained, it subsides. As it dries out, within an El Nino period, for example, it also subsides. When it rains, it grows again. And if you could re-establish wet peat forming conditions, then we'd expect to see long-term peat growth. So there's a lot of information that's held within this elevation change signal. So we can measure that remotely. The idea is that we can measure this on the ground. Because the ground motion is reflecting many things about the state of the ecosystem, we can relate that to the greenhouse gas balance, whether it's taking up carbon or losing carbon, whether it's emitting methane. And our aspiration with all of this is that we can feed this information into a machine learning that would allow us to combine multiple data sets to come up with maps of the condition and status and emissions from peatlands both in Southeast Asia and elsewhere. And that's obviously of interest if, for example, you're a company that wants to invest in an offsetting project. You need verification that what you did was effective either in conserving the system or in restoring it. So part of the function of methodology we're developing is to support that monitoring and verification. Right, Honai, do you want to take over?
If you do this, I carry on after that one.
Right.
Yeah.
Sorry, everyone. As you can see, we didn't have a chance to rehearse this as a result of me being in the air till Saturday. So subsidence, just to give a bit more background then. It's the process by which, as it says here, land or buildings sink to a lower level, and in peatlands it occurs usually through a combination of compaction, which is the peat becoming more dense, through compression, and usually as a result of drainage. It also includes a component of consolidation, which is compression of peat below the water table because the overlying dry peat has effectively become heavier because it doesn't float anymore. And crucially, it includes a large component of oxidation. So that's where the peat that's now above the water table as a result of drainage is exposed to oxygen, and therefore to accelerated decomposition, and that's converting the peat carbon into carbon dioxide. And that's really the core of all the problem, or many of the problems we have with peat drainage, is that it leads to this very large CO2 emission, tens of tons of carbon dioxide per hectare per year, which is the equivalent of many cars driving around for that year. Subsidence is occurring right across large areas of Indonesia and Malaysia, as well as elsewhere in the world. In addition to the carbon dioxide emissions, it's also happening in coastal areas, which are already at very low elevation, which is of course where many of Southeast Asia's peatlands are. It's increasing risks of coastal and river flooding, and that's going to present long-term challenges to the people on the ground who are using that land, partly for plantations, but probably initially mainly for smallholder farmers, because they tend to live close to the sea or close to the rivers. They are probably most vulnerable to flooding. So there's a real urgent need to try to address this or reduce this problem if possible.
Okay.
So
I don't know why. So now the question is, how do we measure peat subsidence? So to do this, or the common approach would be to install some kind of fixed poles. We have used PVC pipes, metal rods, and we insert them into the peat, all the way into the peat, and they're anchored in the mineral layer underneath the peat. It could be clay, it could be sand, it could be bedrock. So, and then we carry on with repeated measurements over time. It could be based on a monthly intervals, and we would get a temporal variation of the peat motion, or we could do it on a year interval, and then we would get absolute subsidence within that year. But the problem is that, as you can see in the video, there is some kind of temporal compaction and disturbance when you approach this metal pole. It's difficult to always measure on the same way, because, for example, people change, or the ground is not even, or which side of the pole should I use to measure subsidence. So we have been like taking 2 or 3 measurements in each one of these manual monitoring stations. And then there is also some problems with major human disturbances. I'm sorry, there were some pictures here, but some of our subsidence poles were destroyed by this road construction, and then some harvesting as well. So this is the manual way of doing it. But then, as part of the PASES project in 2018-2019, we installed 28 time-lapse cameras across Southeast Asia. This was in South Sumatra, Kalimantan, Sarawak, and also in Peninsular Malaysia. And the idea was to use this data to validate peat motion derived from the ISBAS and INSAR. And the cameras were installed in several land uses. This included peat swamp forest, barn, rewetted, old palm of different ages, and different croplands. You can see in the images some of these cameras and locations. And it also included different peatland conditions, drain, severely degraded, waste peatland. And these cameras in here were managed by Dr. Adi Jaya from the Universitas of Palangkaraya. Here you can see the spatial variation of the cameras installed. The cameras in South Sumatra were managed by WRI, and the one in Sarawak by the MPOB. Here you can also see some detail of this study site. For example, the top left is like a small, well, all of them are smallholders, smallholding farms, and some of them are really intensively managed, and some other are like really not that well managed. For example, the oil palm plantation at the bottom left. So that side was particularly wet, and we didn't see much subsidence, but also some results shortly. Here on the bottom right, you can see that a fire prevention canal was dug next to the camera, and then we were able to pick up that sudden subsidence due to the drainage. So what the camera method consists? So we have a fixed metal rod here. You can see here this black ball, and it goes across all the peat into the mineral soil. And then we have like the moving part, and it's like a stool. It could be a chair. It could be something that moves up and down with the peat. On top of this stool, we have the time-lapse camera, and it takes continuous photographs of this fixed metal ball. And we have a special ruler, or we had a normal ruler back then in here. So then we can monitor, or we can check how much that ruler or the numbers in the ruler change in the images. So we published a paper in last year, and it's an open access if anybody is more interested or learning more about the method. Also to mention that we had a deep well here, it's highlighted in blue, and then we were using the same method, taking continuous photographs of the values from that floating device going up and down. So here you can see 3 years, or almost 3 years, of peat motion across different land uses. So we have agricultural land on the top 2 graphs, and then we have some barn area at the bottom graphs. So the agriculture Kalampangan, it was irrigated during the summers, and we can see that the subsidence is much less, or it's lesser than at the agriculture Misik. So we believe that this surface irrigation helped decrease peat subsidence. Also on these graphs, these yellow and orange dots, they are manual subsidence measurements. So in addition to having a camera, we also have like a transect with these poles. And then blue is water table depth, and the black is peat motion. Here, the bottom 2 graphs, we can see the barn area, and here in this exact location is when the fire prevention canal was dug out. So as you can see, the peat motion, or peat, really lower by almost a centimeter due to that, human intervention. But after that, the peat motion remained fairly constant compared to the other barn side that it had also like a lower, or bit lower during the summer months. Here we can see more results from some of these peat cameras, and this is data from WRI, from Suleiman et al. And as you can see, like in the previous graphs, it's clear that peat motion really follows the groundwater level dynamic. So if water level goes down, then peat motion goes down, and after a heavy rain event, then water level will raise, and then also peat motion will raise, like it happened in this forested area. This doesn't mean peat growth. It means that we started measuring at the end of the very dry season, El Nino. So we were at the lowest point. And I'm sure that if we had started measuring, let's say in, 6 months before, maybe peat would be, the time zero would be around here. And then we will have lost maybe 2 or 3 centimeters. So here also we can see this, this coconut plantation. This camera was from a very degraded side, very slow motion. As you can see, the unit here for motion is like half centimeter, but the camera was able to detect that sub-millimeter movement, and it really matched very well the movement of the water level in the ground. This is some of the results from the UK, and I'm going to let Chris talk through this now.
Thank you. So this is a fairly natural lowland bog in Wales. It's a very different system from those you will be familiar with in Southeast Asia. So it has very short moss and shrub vegetation, no trees. But yeah, it has been affected by drainage. So drainage ditches were put in to try to increase grazing quality and for surrounding grassland production, and there's now work to try to reverse that. So what we have here are two cameras, one in the middle of this peatland site, which is in relatively good condition. It's a long way from drains, and then another site towards the edge of the dome, which has been affected by drainage. And you can see that up until where the ring is there, the two were almost identical. So they were responding to a dry period, but they were doing so almost exactly the same way. And then in the middle of the figure there, where it says restoration works, at this point, a local conservation agency installed some bunds to block the ditches in the edge of the peat dome in the area where we had the camera there. And what you can see is that the elevation of that area responded immediately. So within a couple of months, the peat surface in that area had risen by between 1 and 2 centimeters, or even 3 actually at the end. And so that's evidence that the restoration there really worked. It raised the peat elevation up. This isn't peat formation. This is sort of swelling of the peat because it's now wet. But you can see that effect was rapid and it was sustained. So ever since that happened, the camera shows that the peat level has been 2 to 3 centimeters higher, and it's much better able to withstand dry periods now. And hopefully we've got longer term data here that suggests that this may be helping to address long-term subsidence here. So it's about verifying the effectiveness of a restoration measure.
Thank you. So the peat cameras were able to detect changes, and these were below 1 millimeter, or the error was like 1 pixel, and 1 pixel was like really sub-millimeter. Then they were also able to measure groundwater level. We found very similar results to data from commercial loggers. Then we also found that peat motion was highly dynamic and followed water table depth. It responded very quickly to rain events and dry spells. And the peat camera were able to detect differences in peat motion after peatland restoration. This is what Chris just explained. However, there were some limitations. And for example, the data analysis was very labor intense, especially the extraction of water level data. There were problems sourcing commercially available cameras. Most trail cameras had a focus distance, and this is the distance between the camera lens and the ruler, or whatever we want to capture on the image. This distance was between 40 and 60, and we needed distances of 18 to 20 centimeters. There was some temporal compaction of the peat soil when downloading the data, and some of the cameras were found with wrong setting after downloading the data, for example, wrong dates, times, and time-lapse interval. And then there was also some water ingress during camera manipulation. This was due to high relative humidity, rain, wet hands. So based on these issues, we decided to build our own low-cost time-lapse cameras using Raspberry Pi computers. So what is a Raspberry Pi? A Raspberry Pi is like this thing from here. It measures about 6 centimeters by 4.5 or 5 centimeters. It's a tiny computer, and it costs about $40. So we are trying to use these computers to build the cameras, and we are also attaching a different range of sensors to monitor environmental conditions and system performance. For example, we have a soil temperature probe. We can monitor relative humidity inside the camera. We can measure battery voltage. We have also low-cost pressure transducers, and they cost between $40 and $50 each. We are using telemetry when possible, so either 4G, or if there is no 4G, the system will try to connect to 2G or 3G networks. All the data is being saved into a micro USB drive, which can be replaced, swapped in the field very easily. So you don't need to open the camera, you just go, remove the USB, fit in another one, and then go home. And then these systems are solar powered and run autonomous for most part of the time. And then we are automating the data analysis to reduce this labor costs. So the process of these peat cams is that these cameras are on a sleeping mode, so they will wake up every 2 or 3 hours intervals, and this can be changed based on user requirements. Then it will take a photograph, and it will add all the site information, name, date, temperature, whatever we want to add on the image. Then it will measure all the environmental variables, and for now we have air temperature, humidity, atmospheric pressure, soil temperature, water pressure, and battery voltage. If humidity inside the camera is above 90%, the system will send an email to the user warning like humidity is too high, you need to do like a field visit to replace the silica gel that we have inside the camera, or to assess potential problems. Once all this is done, the camera will upload the data into a cloud service. We're using Dropbox, but other services could be used. And then the camera will go into sleeping mode and schedule the next waking up event, so it doesn't waste energy. So here I'm just showing some of the manufacturing photos of the cameras. We have been working really hard to get some of the first units built. So, it looks really complex with a lot of wires, but it's not as complex as it looks. And we are doing an improvement of this design. We are going from this prototype on top, which has all these wires, into having this print circuit boards that will reduce or will increase the system performance, will avoid loose wires or connectors, and will help us scaling up production. However, the main limiting factor for these cameras will be the availability of Raspberry Pi computers and chips. So here is some of the new cameras. This is our colleague Nathan. He has been working very hard on getting the first prototypes, and it's the same principle as so earlier. So we have the camera is this white box with the solar panel on top that sits on top of the chair or stool, and the chair is inserted, or the legs of the chair is inserted into the Peat, and it will move up and down with Peat motion. Here we were testing the cameras and the transducer. That's why we have these big white barrels. And here, well, so far we have installed about 22 cameras in the UK, and we have put them at the land use classes. This has included degraded and restored blanket bog, wet and dry grassland, cropland, waste pit. 8 of these cameras have been installed next to Ecovariant flax towers. And then we are hoping to install between 50 and 60 more Peat cams this year, but the final number will depend on the availability of Raspberry Pis. Here you can see some of the images or the UK study sites. So this is one of the grassland, dry grassland, wet grassland. This is also wet grassland. This is blanket bog, and it was very cold. This, I wasn't expecting to find the snow, but it was like -5 degrees. So we have tested cameras in this very cold extreme, and now we need to test them in very hot conditions, like in Southeast Asia. This is what the camera is capturing. So we have this special ruler with these Aruco markers. This is like a QR, so we can detect where they are in the image. And we are using an LED to, as a flash, so we can also take night photos. So here, I hope it's not too disturbing, but you can see, well, I made a time-lapse video using images from one of the wet grassland sites, and here highlighted with this red circle. If you look at the numbers 17 and 16, you can see how they move up. Well, the camera is subsiding, so that's why the numbers are changing. And on the right, you can see how the data from these images, how it has been extracted using Python and OpenCV or computer vision. So within 1 month, we had about 6 millimeters of subsidence in this wet grassland. So all this data captured by the cameras is being uploaded automatically into, in this case, I said it was Dropbox, and each camera has its own folder. So we have written a web app that can be published online, and users or internal users or public in general could have access to this data and see real-time data of Peat subsidence, water table depth, and you could select where do you want to check the data. This is, well, some of the flax towers that we are managing at UKCH, and the idea is to put one camera next to each one of these flax towers. We will also have all these real-time data plotted automatically, so then you can choose what's your scale, what's your date, and then you can just assess or have a very good interpretation of, what's the camera doing, what's the Peat surface doing, is it going up, down. Here with the battery voltage, we should be able to troubleshoot the camera. For example, if one of the cameras stops working, we could assess why it stopped working. Is it because the solar panel is damaged or the battery is damaged? And the same with all the variables. So this is all about the Peat cameras, and now just some slides about what we are hoping to do next and how communities could help with monitoring peatland. So, for example, stakeholders are necessary to effectively monitor peatland conditions. One of the main reasons is that they know where peatlands are located. Peat maps are not 100% accurate, and they have local knowledge about past disturbances and how these peatlands are currently being used. They provide non-woody products such as fish, medicinal plants, edible ferns, etc. And they can help in establishing extensive and long-term monitoring stations to quantify both peat motion and groundwater level. Community members can contribute to the ground truth measurement. For example, during the COVID pandemic, we were counting on Dr. Adijaya, and he was counting also on local farmers who were helping with the measurement of these peat subsidence. We were in touch by mobile phone. We were, in touch almost every week, and the research has carry on during all the pandemic, and we will have 4 years of peat motion data next October, thanks to the help of all these stakeholders that were involved, in this case, universities and farmers. And the way forward. So this is what kind of summarizing what we said earlier, what is the future of using technology to monitor peatlands? So our main objective in the long term is to be able to estimate carbon dioxide emissions from peat motion and remote sensing. So we need to develop sequential transfer functions required to link ISBAS outputs, all these remote sensing, the radar data, with the peat motion and carbon dioxide and probably methane balance. And we expect these functions to vary by land cover and climate region. And we will achieve this by collocating peat cameras and flux towers across all regions. I'll show you a map in a minute. So we can derive these essential functions, enabling us to map and monitor peat greenhouse balance at point and regional scales. So we want to go from the ISBAS derived data, combine this with the peat motion data and the measured carbon balance using the flux towers, and then be able to map what's the greenhouse gases for a specific regions. This is from Nature Geoscience, and it shows the peat subsidence across the area. So I'm gonna let Chris to conclude with this slide.
Thank you. This is the ambition, I think. So we are very keen to expand the network of these sites. As Honai just said, it's partly about linking to Earth observation, but it's also, I think, valuable as a sort of site or project level managing tool with or without satellite data. So if you're running a restoration or monitoring project anywhere, this is a useful and fairly cheap piece of kit to use. So this map was prepared, I don't know, maybe 2 years ago, and we were negotiating some financial support from Shell, who were interested in this in relation to their own offsetting work and as a verification tool that could be used more widely. So this was the ambition then. After that happened, COVID happened, so we haven't put all of these dots on the map in reality, but we do now have sites in Indonesia, Malaysia, the United Kingdom, Ireland, Sweden, the Falkland Islands down in the South Atlantic, and there's many possibilities to install additional cameras. Actually, the problem isn't sites. The problem, as Honai mentioned, is resourcing components for the cameras because of the global supply chain problems. But where we would like to get to is something like a global network of these things, which would be operated by partners for their own benefit, but hopefully feeding into a sort of global database of these sites. So something like FluxNet for an Asia Flux for carbon dioxide flux towers, and building up a data set and an understanding of what's happening to peatlands around the world.
Yeah, thank you, Chris. And then just to conclude, some take-home messages. For example, drainage of peatlands leads to irreversible peat loss and subsidence. Continuous peat subsidence will lead to loss of agricultural land and crop yields due to recurrent or permanent flooding. Peat motion is very dynamic and responds very quickly to changes in groundwater levels. Technology like peat cams can help us understand how the peat surface responds to changes in land use, climatic conditions, and management practices. Peat cams can help validating and refining other technological applications such as INSAR and ISBAS, which can be used to estimate peat motion and subsidence over large areas using freely available data from Sentinel, for example. And then local communities and stakeholders can help running and maintaining peat camps in remote locations. And here, just to conclude with an image of one of the cameras installed in South Sumatra and how the local stakeholders were helping us installing the cameras, and then they were also helping maintaining them when we had, need for some help. And well, I would like to thank Nathan, our colleagues at CEH, and then Kristen Davis from CEL, and Dr. Adi Jaya from University of Palangkaraya, and then to all of you for listening and for the invitation to present today with Chris.
Thank you so much, Dr. Hone and Dr. Chris. That was such an interesting presentation. I know there's already tons of questions in the chat box. And of course, we'll also have a time for a Q&A. So if you have more questions for both doctors, you can hold on to them or put them in the chat box and we'll address them during the Q&A. But that was a really, really interesting presentation. And I really love how a lot of the technology that you're talking about, Raspberry Pi, a stool, and just cameras are very accessible and technically publicly available if it wasn't for, the global supply chain issue with Raspberry Pis. But that makes it more easy for people around the world to have these setups, because you also mentioned how typically this kind of equipment is tens of thousands of pounds or euros, and it's really quite difficult to get that installed in a lot of different places. Whereas this, as you engage more stakeholders and with the community, it becomes easier to get more data, and then all that data, you make it publicly accessible. And I think that's so important. That's such a key thing, especially for our People for Peat project. That's what we're trying to do as well, right? To make that kind of data publicly accessible. So thank you both so much for sharing your work. That was really, really insightful. And I'm sure there are more questions to come. So everyone do keep your questions for later, and we'll have a further discussion. So thank you, Dr. Chris and Dr. Hone. So now on to our next speaker. We have none other than Professor Engineer Dr. Aduwati Salih, who is currently a professor at the Department of Computer and Communication Systems at the Faculty of Engineering in University Putra Malaysia, or also known as UPM. And she also holds a PhD in mobile and satellite communications from the University of Surrey in the UK, as well as a master's in communications and network engineering from UPM. And then she did her bachelor's of engineering in electrical electronics engineering from the University of Edinburgh in the UK. So she's very well positioned today as well to speak about our topic. She also happens to be the principal investigator and collaborator for many projects under multiple local and international funding bodies. And she's given consultations to the Malaysian Ministry of Information and Multimedia, the Malaysian Ministry of Higher Education, the National Space Agency, as well as other private companies such as Petronas on projects related to mobile and satellite communications. So her research interests generally are 5G and beyond, radio resource management, MAC layer protocols, satellite communications, satellite-assisted emergency communications, the Internet of Technology systems for environmental monitoring, and 3D video transmission over wireless networks. So a lot of different strengths that she's going to bring, and I'm really excited to hear of her presentation. So Professor Aduwati, I will hand it over to you.
Thank you, Mariam, for your kind introduction. Let me just share my slides. I hope you can view it. Okay, so thank you to Dr. Yone and Prof. Chris, for your very insightful and interesting project on the peat camps. So for my presentation, it will be entitled NetPeat, Network ASEAN Peatland Communities for Transboundary Haze Alert. I am one of the researchers of this project. It's a regional project, consists of Malaysia, Brunei, Indonesia, and Japan. And government of Japan specifically funded this project. And it is actually a continuation from our previous project, which ended in 2021. And then we recently got funded again in 2022. So this is the outline of my presentation. So you can see here the long list of our project members, right from Malaysian, from UPM, from MIMOS, USIM, and Met Malaysia, Meteorological Department Malaysia from Malaysia. And then from Indonesia, we have IPB University and their stakeholders, okay, from the Fire and Rescue Department, from the Forestry Department, as well as Meteorological Department, and also from UTB Brunei. So all this long list of members shows that how our project is extending and expanding because we want to consider more aspects of peatland forest management in the region in our study. So taking that into consideration, so this project comes into interest when we encountered transboundary haze issue in 2019. We noticed that how the region is going through very bad haze situation, and hopefully it won't happen again. And how is it that we can improve it, especially in terms of the peatland management? And we look into the potential of technology, and in this case, the IoT, Internet of Things. Like, for example, Yone and Chris is now talking about pit camps. And in our project, we are using sensors and we integrate it over the internet, as we call it, Internet of Things. And then from this IoT system, there are several issues that we're investigating. The first one is the use of LoRa technology. It's a wireless access technology, which is freely available depending on the country, the frequency spectrum that you can use, as well as the transmit power that you can use. So we investigate that in terms of LoRa transmission over the forest. And we are also looking into the data itself. So after we have collected the peatland data over several number of years already, so what are we going to do about it? So this is all the project has been working on, and it is still ongoing. And we remember all these news excerpts in the region, how the skies become red because of these haze issues. And then how it affects, to me personally, it affects my children because they are suffering from asthmatic problems, and it becomes exacerbated during the haze season. So from this episode, the team has been trying to improve the peatland management system, especially in the 3 countries involved in the project. And we chose our proof of concept in the 3 peatland forests. In Malaysia, we chose Raja Musa Forest Reserve. In Indonesia, it's in Jambi, and in Brunei, in Badas. So all these peatland forests are selected based on our discussion with the stakeholders, especially the forestry departments. So basically, this NEPC and NetPeat project is an IoT-based solution. We are looking into technological innovation, especially on the IoT part, on the LoRa access technology, as well as on the data analytics. And we are also trying to engage with the stakeholders right from the beginning of the design. So we have both technological and social innovation, and I feel so humbled when listening to Yone and Chris' presentation just now, because their project was like vast implementation and deployment. So we hope that NetPeat can learn from you on how we can have this deploy in a wider scale, so that we can see a more impactful benefit. So what we did is we replicate the IoT in the 3 chosen peatland forests in Jambi, in Raja Musa, and in Badas. So of course, the design, the IoT design or the network design is similar, but we customize it and localize it according to the local scenarios. Like for example, in Malaysia, we deploy it in Raja Musa Forest Reserve, which is around 1 hour drive from UPM, where I am based in. And then we have the sensors, basically the piezometer connected to the LoRa. And we also have the receiver or the LoRa gateway, and we put it on top top of a tower here, if you can see, I'm circling here, on top of a tower, because we want to make sure the coverage, the LoRa coverage covers a larger area in the peatland forest, because that particular peatland forest is reserve forest, forest reserve. So the area is huge. So we have to make sure, based on our limited resources, we have to deploy the sensors at the most probable area for forest fires. So from the collaboration, from the discussion with the forestry department, we chose this particular site, because we want to maximize the coverage of LoRa. And we correlate the data with weather data, weather-related data. So we also put up a weather station together with the LoRa gateway collecting the peatland data. So this is how it looks like. And this setup is replicated in both Jambi as well as in Badas. So our partners in Indonesia, which is IPB, I think some of the audience is staff or students from IPB University, as well as UTB, University Technology Brunei. We have Dr. Wida and Prof. Lailan, who are working so hard to deploy this IoT system in respective peatland forest. So from this deployment in the 3 regions, in the 3 countries, we come up with an integrated peatland data management. This is conducted by our partners, Mimos, Berhad, as well as USIM, Dr. Nordin, as well as Prof. Hafizah. So, and we also had some help from our Indonesian partners, BPPT, earlier on the project, on how to develop this dashboard. And of course, we know that some data, we need some governance issues, which data can be communicated, which data can be shared, and which data cannot be shared or probably just accessed at admin level. So we have this discussion on how we can manage and govern the data more effectively. So from this dashboard, we also push the alert system to the Telegram. We use Telegram to alert our stakeholders, especially the local communities, the forest rangers, on the level of groundwater level, so that it can be triggered. It can be triggered and necessary actions can be done. So that's our aim, from the first part of the project. And we have successfully, alhamdulillah, even though it was during the pandemic, we had several webinars, if you can see here, hosted by Indonesia team, Brunei team, Malaysia team, and this was in Malaysia, and recently we just concluded our workshop in Brunei just last month. So we have these interactions and collaboration, as well as best sharing of best practices in the region by all our members, project members, as well as stakeholders. So I'm really amazed by the peatland community, because you guys have been very close-knit society or close-knit community that always share with each other, because my background is in mobile and satellite communications. I happen to be in this project because my knowledge in the IoT part is needed. So when I jump into this peatland-based project, I can see that the relationship is very strong, and this is something that I'm really amazed and best. So moving on with the NetPeat project, which is recently funded, we are looking into the wireless technology part, or wireless access technology, using the LoRa access technology, as well as on the big data analytics part. So in the first one, when we are looking into LoRa, we want to optimize this access technology to cover as much as possible of the area, because bear in mind, in Malaysia, for example, the peatland forest is huge, and we want to make sure that the sensors that we are putting up, it can cover quite a number of area in terms of wireless access, wireless coverage. So we have, you can read more our findings here, but what we did was we tested in several areas in the peatland forest and how we can optimize the transmission. So this is done by one of our members, Dr. Luman. I think Dr. Luman is here, on how we can optimize the transmission parameters, the channel, the data rate, as well as the spreading factor, so that it can still be transmitted. We want to make sure that the data can still be transmitted, although it is in the thick forest of peatland forest. So that is in terms of the LoRa optimization. And after we have collected the peatland data, we are looking now into the data analytics part. So this is done by Dr. Liu, Dr. Sharifah, as well as Dr. Shariza. So we are looking into the data analytics, especially if we could estimate a potential estimation of groundwater level, because that is the main parameter that we are collecting. So we try to estimate the groundwater level with respect to other parameters, especially on the rain precipitation. So we use this threshold, with the help of GEC, Global Environment Center. So thank you to GEC. And then we try to estimate. So this is still an ongoing project, an ongoing research activity on how we can further improve the estimation technique. And you can also find this findings and output in our publication. So of course, when we are estimating in the near future is better compared to the far ahead. So this is also something that we learn from our Indonesian counterpart, because Indonesia has been very well advanced in this research topic. And as for now, we are looking into the peatland data analytics for forest fire estimation, and we are looking into potential integration with fire danger rating system, FDRS. And Alhamdulillah, in the second part of this project, we got Met Malaysia to come in place, to come on board. Meteorological department in Malaysia, in Brunei, as well as Indonesia, they are part of the project. So we got their input, especially on how to estimate the fire weather index, FWI, considering the groundwater level. So this is the current challenge that we are facing. Like, for example, how is it that, for example, the current FDRS is using weather-related data, the humidity, the ambient humidity, the rain precipitation, the wind direction and wind speed, and etc. So how can we integrate that with the ground data, with the ground peatland data, the groundwater level, for example? So we have been working really closely with the meteorological department. So you can see here the meteorological department in Malaysia, and we are looking into integrating how groundwater level can be an input to the calculation of FWI. So this is our challenge, the mission that we are going to do in this remaining part of the project. So apart from that, we are also working with Fire and Rescue Department, because we want to learn and help improve the fire suppression techniques once fire occurred. So in terms of FWI versus the ground and weather data, so this is what has been implemented in our IoT system. Yeah, this is from our IoT system, right from the ground sensor, and we correlate with our weather station data, and we also have our automation in terms of the water pump, to help with the forest ranger and the local community to inundate the area with water to avoid further worse groundwater level. And we would like to integrate this ground and atmospheric data with this FWI related input. So we have been correlating our IoT system with the meteorological department's weather station, because we want to make sure that the IoT system is validated and verified. The data from the IoT system, especially the peatland data as well as the weather related data, is correlated with the meteorological department data. So we have been closely with Puan Zana. Thanks a lot, Puan Zana, for linking us with these two systems, and we so far the correlation is good, and the next step is how we can further integrate this groundwater level with the fire weather index. So we really hope that if you are working in this area, we can discuss further and we can get more ideas on how to do it, because the FWI is innovation by Canada, right? Canadian FDRS. So maybe some of the parameters, it has to be localized rather than using a generic parameters or the variables used in the original FDRS system. So this is what we are challenging ourselves to do. And we have been working closely with the meteorological department and the forest fire department. So these are some of our publications. If you would like to know more about our project, And Alhamdulillah, we also have copyrighted some of parts of our project. And this project, Alhamdulillah, it has received quite a number of recognition locally as well as regionally. We have our partners from Brunei, Dr. Rida, which has been selected twice in a row, twice in 2 years, as the national finalist for the ASEAN US Prize for Women. And the project has also received several certificates or medals in the local and international exhibition. Okay, so this project is also the basis for my application to this prize. Yeah, the same with what Dr. Rida has enrolled, US ASEAN Prize for Women, and it has been recognized as one of the regional finalists under the Clean Water, Clean Air theme for the region. And apart from that, we are also looking into awareness and also especially to the local communities about how we can integrate the technology with the peatland forest. So for example, before this in Malaysia, if you're talking about peatland forest, they will not, especially the local communities, they could not imagine how it can be integrated with the IoT, for example. Perhaps when we first deployed this system, they don't know what IoT is all about. So we want to make them aware that technology is there to help them, especially to help to better manage the peatland forest. We are not there to, the project is not going to replace the manual peatland data collection, but it is meant to complement, because at the end of the day, the IoT collected data, especially the ground data, the groundwater level, the soil humidity, the soil temperature, we still need to validate and verify the data, to ground truth the data, so that we know that the data that we are collecting is valid. Because it so happens that during the pandemic in 2020, and especially in 2020 and 2021, we got the data, but everyone is working from home. We see the data is coming, but we see that how come it is too good to be true. To be honest, when we say that it's too good to be true, but the data seems like a little bit erratic. But when we go there, when the traveling is allowed, some relaxation in the traveling, it seems that the ground sensor is being pulled out by the wild boars, by the wildlife over there. So you see that we still need to go there probably once a week or twice a week. Once a week or once a fortnight, or the worst case is once a month, to ground truth the data, so that we can still say that the IoT system validates and complements the manual peatland data collection, or vice versa. So that's the challenge that we encountered during the pandemic. So if we have time, I can play this. Let me just stop sharing for a while and then share with you the promotional video. Okay, Mariam, let me know if there is any problem, but I think it should be okay. Oh, sorry, I think I forgot to share with the sound on. Just try again. Share sound. Okay, you can hear it,
Yes, Prof, I can hear you.
Okay, sorry.
Saya Duati dari WIPNET Fakulti Kejuruteraan UPM. Projek ini bertajuk NAPC, Network ASEAN Peatland Forest Communities, dibayai oleh Universiti Jepun dan kolaborasi antara UPM, MIMOS di Malaysia dan juga IPB, Universiti Pertanian Bogor dan BPPT di Indonesia, dan di Brunei kita ada UTB, Universiti Teknologi Brunei. So 3 negara, Malaysia, Brunei dan Indonesia, kami akan melaksanakan IoT based peatland monitoring untuk memantau paya gambut di negara kami. So di Malaysia kita telah mengenal pasti hutan simpan ataupun hutan paya gambut di Raja Musa ni, di Kuala Selangor, untuk kita pasang IoT sistem supaya kita dapat pantau kedalaman air di dalam tanah paya gambut. So di atas ni kita ada weather station, stesen cuaca, dan juga alat-alat LoRa untuk transmission ataupun penghantaran isyarat daripada sensor di bawah di dalam paya gambut ke gateway dan juga weather station, dan kita hantar ke cloud. Di cloud itu kita akan push kepada control center. So control center akan berada di UPM ataupun di MIMOS, dan ada juga cloud server yang kita parkkan kepada NICT Jepun. So ada beberapa tempat yang kita storekan data ini, dan data yang diterima kita gunakan untuk ramalan kepada kebakaran hutan. Kebakaran hutan ini kalau dari segi skala besar akan menyebabkan jerbu. Dan macam yang kita tahu pada tahun 2019 jerbu yang teruk berlaku di Malaysia, bukan saja di Malaysia tapi juga di Indonesia dan Brunei. So kita diharapkan dapat daripada IoT sistem ini akan dapat mengawal dan juga mengawasi hutan paya gambut daripada terbakar.
Saya akan explain main components of our system ni. So dekat sini kita ada dua item. Yang pertama ini kita panggil sebagai weather station lah. So fungsi weather station ni dia akan mengambil data berkenaan hujan, temperature, humidity dan wind direction, dan ada beberapa perkara lain lah. Sebab apa data ni penting? Data ni akan memberi maksud berkenaan keadaan semasa cuaca di kawasan ni, dan dari data ni kita boleh buat analisis dan predict lah sama ada akan berlaku kebakaran, risiko kebakaran tu tinggi dan sebagainya. Dan ini pula adalah dipanggil LoRa Gateway. So LoRa Gateway ni apa fungsi dia adalah dia akan mengumpul data-data daripada sensor yang kita pasang di bawah, dan sensor ni kelebihan dia kita boleh pasang sensor sehingga 5 km. So di kawasan yang tak ada mobile coverage kita boleh pasang, dan dia akan capture data daripada sensor tu setiap 15 minit, dan dia akan proses dan kita akan hantar ke cloud lah. Dan ni adalah antena dia. Kalau kita tengok bahagian atas ni, so antena ni boleh cover up to 5 km.
Our role in this project actually is developing the platform. We have developed the platform by using MIMOS, MyMIS platform, and from there we process data and to display to be used for the rangers. Some data to be used by them in managing this forest reserve. At the meantime, also we provide the alert whenever a system trigger any anomaly or something wrong, to be sent directly to dashboard as well as to the end user mobile phones.
Dulu pemantauan yang dijalankan di kawasan hutan simpan Raja Musa ni, kita melakukan pemantauan kebakaran ini dengan mengadakan rondaan di kawasan-kawasan ini, dan juga kita juga membuat pemantauan menggunakan piezometer secara manual di sini. Sekarang ni kita di kawasan Raja Musa ni telah menggunakan sistem IoT, iaitu sistem yang telah dibangunkan oleh UPM dan MIMOS. Apa yang kita dapati bahawa dengan menggunakan sistem ini memberi maklumat secara terus kepada pengguna lah, pada pengguna, dan ia memberikan amaran dan juga tindakan yang lebih awal untuk kita mengawal kebakaran. Jadi sistem ini sangat berguna, sangat mempercepatkan dan mempermudahkan pemantauan dan juga pengawalan kebakaran.
Okay, I think that's all. Mariam, thank you.
Thank you so much, Professor Adewati. That was, again, a very interesting presentation. And it was really cool to see all the different collaborations happening as well. So thank you very, very much for sharing with everyone today.
Thank you.
So I'm going to launch just a quick poll before we go into our next Q&A session. So this is a bit to do with our previous presentation, which is, who do you think is most responsible for mitigating peat subsidence, whether it's government agencies, financial institutions, research institutions, landowners, smallholder farmers, or unions, or NGOs? So I'll give you a little bit of time to answer this poll, get your insights. And of course, everyone, please feel free to put your questions for Professor Adewati, Dr. Hone, as well as Dr. Chris in the chat box. I know both Dr. Hone and Dr. Chris have very kindly addressed a lot of the questions already, so thank you so much. But yeah, feel free to add any more to that, and then we can have a discussion after this. So I'm just going to end the poll for now. And I would say most of you answered, 80% of you answered that government agencies are the most responsible for mitigating peat subsidence, and then followed by followed by landowners, especially because it's on private land. That makes sense. And then research institutions. So, I mean, I'm curious actually what our speakers think about this. Any comments from Dr. Hone or Dr. Chris or Professor Adewati?
I'll have a go. I think it's a collective responsibility, really. I think it depends where you are. I think last week I'm on an advisory group for April, the big pulp and paper company who operate in mainly in Sumatra. They manage huge areas of the land, and I think within those areas they have primary responsibility because they are the concession holder. But they need to do that in collaboration with communities, with government in other areas where it is mostly community land, like in central Kalimantan. Then I think it needs government agencies to take ownership of the challenge, because it's individual farmers don't have sufficient control over their water levels to do that. So I think it depends where you are, but it's kind of everybody's problem, I think. And to some extent, the people who are, buying the products produced by the companies operating on peat also bear responsibility now. And I think, the big commodity companies and the customers, some of whom are in the West, also have some responsibility to support responsible management of the land where their products are coming from.
Awesome. Thank you so much for that answer, Dr. Chris. I think that absolutely makes sense. And that's, again, what all of our projects are kind of trying to do, right? To bring together all these different stakeholders and agree on how to best manage our peatlands. Great, thank you. So one last poll before we move on to the Q&A session. And I will launch it right now. And so the question is, do you have any experience for our audience? Do you have any experience in tech applications in any of the following fields, whether it's peatland fire monitoring, peat water table management, data sharing, carbon storage monitoring, live feed on peat status, or none of the above? Just curious where our audience is coming from, whether they have some experience themselves. So that's always interesting, because even our team very recently went and visited Vietnam, where we saw a lot of technology being used to monitor the fires or monitor the forest area to make sure that there's no fires happening. So very interesting. So I'll give it a couple more seconds before I end the poll. Still some people trickling in with their answers. Okay. So I'll end the poll right now and share. So we've got quite a lot of experience in our audience so far. So we have people who've been working on peat fire monitoring already, as well as data sharing, and then people working on both peat water table management as well as carbon storage. So very cool. We've got like a really captive audience here because they already kind of know what's going on with their internet things and using internet and technology to conserve peatland. So thank you so much. All right, so now we'll move into our Q&A session, which I know everyone has been waiting for. So we've got a lot of questions already out of the way. So apologies if I accidentally repeat some of them, but let me go to our first question. So this goes towards perhaps all. I think this is a really good question, which is, can the IoT system and Peat Cam be integrated in some way? So I assume this is for kind of directed at both all three panelists, right? Is there a way to integrate both of your different technologies together? Is there an opportunity to work together or learn from each other? So maybe Professor Chris, you want to start with that?
Yeah, I was thinking the same thing as I was just listening. I mean, that would be cool. That would be great. Yeah, I think the way I would view the peat cameras is it's one more tool in the toolbox for monitoring peatland ecosystems, and clearly the more that could be integrated with all the other tools through an IoT approach, then the more useful it will be. So yeah, definitely.
Awesome. Any comments from Dr. Hone or Dr. Adewati?
Hone, would you like to start first?
No, okay. So for just clean up on what Chris said, one of the things we want to do is that the Raspberry Pi should be able to do all the data analysis. Mm-hmm. So instead of uploading an image, it should be able to upload the data, and that can be sent directly with a LoRa model into the gateway, and then everything would be collected. So the next step as part of the projects we're doing would be to have, very similar to what has just been presented from Raja Musa and other location, having the gateway installed next to the flags tower, and then have a range of sensors across the peatland area. I think it's much easier in the UK because we don't have very tall trees, or some of the peatlands areas are like a little bit flat kind of thing. So it would be easier to have like a better coverage, 5 kilometers, maybe 7 maximum. So it should be very easy, and then it would also help reducing the running costs, because at the moment we need to pay for a data plan. So each one of the cameras has a GSM model. We need to pay maybe $10 per month for this internet plan. So having a LoRa system integrated with the Peat cameras is the natural way forward, once we have these final designs for the Peat cameras.
Yep. If I can add on that, Mariam, yes. Because we've been also deploying our IP camera, but it's just like a very low resolution camera in the area, but it's highly positioned because we want to cover a larger area, just like a normal CCTV, if you want to call it that way. But if we could integrate it with Peat cams, as what Yone and Chris was discussing just now, so it will be really good. But I'm also thinking the challenge, because engineers, we do love challenges, we do love problems. I can see that the challenge would be in terms of the deployment, especially in the wireless point of view, just like what Yone was telling just now, the configuration of the LoRa department, because images, they consume more bandwidth compared to data. For example, if you just transmit groundwater level data every 2 minutes, it shouldn't be a problem. But when you try to transmit videos or images, then there are some optimization of transmission parameters that we have to address. Yeah, but this is a very good research topic that we can investigate on.
Awesome. Thank you, Professor. So that's already an exciting and positive outcome of today's session, is at least connecting all these researchers together. So that's great. We have another question coming from Robert Vandenberg from This Is It Technologies. And he asks, I think specifically to Prof. Adewati, is the pump system active and sufficient to keep the water level at preferred levels?
Currently, the current system that we are deploying is to alert the forest rangers on their telegram on the mobile phone if the water level drops at a certain value, as what GEC has advised us. So they will trigger the water pump. So the amount of water that is been inundating the area is subject to the person's preference based on their experience. So in this current project, we are looking into more studies as to optimize the amount of water to inundate the area. So we have our peatland forest fire suppression experts, Dr. Zahir Asri, as well as Dr. Faiz from the Fire and Rescue Department to investigate into this as to how large area they want to inundate the area, how much water is needed to pump, to release the pump into the area. So this is also an ongoing study that we are looking into the next few months. Mariam.
Very cool. Very cool. Thank you for sharing that. So we have another question. In fact, we had quite a lot of questions in the chat box that I know both Dr. Hone as well as Dr. Chris have already kind of addressed. But there were a lot of questions about whether the cameras that you install are affected by rising or sinking due to peat motion. I mean, obviously that's what you're measuring, but has it ever come to a point of like, the cameras falling off? Or like, I think some people talked about it getting, or rather you've talked about it getting taken by wild animals. What are some of the challenges for those devices? Now, the issues of the supply chain for Raspberry Pi. What are some of the challenges that you've seen from just using those cameras?
Shall I go, or Honai, do you want to say something?
You can go
I mean,
first.
I guess the first thing to say is that, as you mentioned, Marianne, the aim of the system was to produce something that was cheap, and that was partly just because we didn't want to spend too much money, but it was also because we did want to develop a technology that could be used by local partners who didn't have huge budgets, or wherever in the world, because I think that is a big problem actually with research, that if everything is very expensive, then there's only a few research groups globally can do it, then that's not very useful for people trying to make change happen on the ground, which is an indirect way of saying that we figured if they're quite cheap and we put lots of them out and a few of them get destroyed by monkeys, that's not then the end of the world. And that is what happened. We put out 26 and we lost 2, I think, if I remember right.
That's a pretty decent loss rate.
So some acceptable casualty rate. Obviously we try to protect them as much as we can, and we're still looking for how best to do that, but it hasn't. I thought it might be worse actually than it was. But I think that they're reasonably robust. But yeah, Honai, do you want to say more about the?
Yeah, I think they resist quite well, all the tropical climate in Indonesia and Malaysia, the ones, the commercial time-lapse cameras. So the new ones we are building, they're better built, they have some silica gel inside, so they will keep the system dry. We have problems with ants going into some of the old cameras. Other kind of insects. How did they go in? I don't know. They just find every little hole you can imagine, and they just go in and they make a nest. With the new systems, we're trying to go a little bit higher with using IP68 waterproof rating, and it's increasing a little bit the price. But if we can combine a range of sensors and then integrate LoRa, then that extra money would be worth it. And if we lose some of the cameras, as Chris said, well, it's not the end of the world. None of the cameras has been stolen so far. And we have cameras in many different countries, so that's a good thing. And yeah, monkeys are curious. So I think it was the sites in South Sumatra. They just wanted to go there, maybe because of the flash or because of the yellow color of the ruler. So they were just playing with the setup. So it's trying to make things as robust as possible. I also remember visiting some sites in Raja Musa. It was from a different experiment, and they have like a cage protecting the. I think it was the piezometer. I think it was from the same university from Adwati. So yeah, there are options to do it, but to protect against animals, but nothing, after 50 years of having a camera in a race box in the UK, maybe you would see some of the moss growing, like absorbing the camera, but that's not happening, and it's not going to happen in the time frame we have. A tree could fall in Malaysia, and then of course if we just bury, if we just sync the camera and add it to the carbon stock.
I mean, worst case scenario, then your cameras would also double up as wildlife camera traps, right? So it's still okay. I think even in Malaysia, there are sometimes they do camouflage the camera traps, right? So that elephants don't get annoyed and be like, what is this? And then push it off. So that could be an option as well. But thank you so much for sharing your experience. It's always fun to hear from researchers in the field and, the challenges that you guys face. So thank you for that. One of the questions I also wanted to ask is, all three presenters have talked about all this technology that you're trying to push forward for peatland conservation. But what are some of the challenges that you see, especially because, for the future, you guys are thinking about mainstreaming this technology, right? To make it more accessible, to put it and install it in more countries. What is the main challenge to getting that mainstreamed right now for you guys? So maybe start with Professor Adewati.
Thank you, Mariam. I think from our experience is we noticed that the stakeholders, they do want to embrace technology, but there are some red tapes that we have to go through. I'm not sure about the other countries, but at least the one that we are facing. So this is one of the challenge. But of course, through close engagement, especially when we go there and explain and how exactly we're going to deploy it. And of course, Raja Musa is a forest reserve. They want to protect it as much as possible. So the more that we engage, the more that we invite them over projects or programs, then they know better. And it has been quite well received. In fact, some of other forestry departments has been asking us, is it possible to deploy IoT to help them monitor their peatland forests in other parts of the country? So I think it's a challenge, but it's also an opportunity for us to reach out to more people, especially the stakeholders in the country and in the region.
Awesome. That's really nice to hear. I mean, despite the red tape, that there is interest, right?
Yeah.
And that's like your first challenge already taken care of. So that's really exciting. I'm glad to hear that, Professor.
Yeah.
Over to Dr. Hone.
Yeah, so I think that our experience with stakeholder has been really positive. Like, I keep getting messages from colleagues and friends in West Kalimantan saying, oh, when are you coming back? We want to carry on doing more research. When are you, having new projects? So they are really keen on adopting and this kind of technology or projects, and they want to be part of it. And I think some of the problems in the past, many years ago, or maybe not so long ago, is that foreign researchers were doing research. They were not involving local researchers, local communities. So I think that needs to stop. And, we need to treat each other as equals, as partners, and then sharing all the data with the communities, giving back to them. And so when this is what you're finding on your research or on your peatlands, and this is why you have to protect them, either because we have identified acid potential sulfate soils in some of the locations, or because water is polluted, or because if peat keeps subsiding, then the land is going to be flooded. So I think they are very interested, these stakeholders, and maybe the most challenging one would be the companies. Maybe those are the more challenging stakeholders. How to work with them or integrate these kind of experiments within their land. So I think that's maybe it needs a little bit more more work.
Yeah, no, that makes sense, especially because, for the local stakeholders, like you mentioned, they have a literal stake in your research, right? Whether it's, their land that's being affected or their livelihoods that are being affected. So of course, that makes sense, whereas companies can hide a little bit behind, an organization. So that's an interesting challenge to have. Dr. Chris, any comments on that?
I think Hanai summarized things quite well. I think for sure the red tape can be a challenge, particularly if we're operating or hoping to operate in multiple countries. Every country has different red tape we have to navigate. That's just how it is. But I think working in partnership with local research organizations, NGOs, companies, communities is the way to go with this. And that was always the intention. Yeah, perhaps companies are the most difficult, partly because they are quite cautious about exposing themselves to external scrutiny, shall we say. So if an open source monitoring system goes onto their land and someone at the Ministry of Environment and Forestry or wherever starts looking at the data and thinking, that's not what's supposed to be happening, then that's a problem. And we very much intend for these data to be open source as much as possible. So that's probably the biggest challenge. But yeah, I mean, generally our experience has been quite positive, because I think people who we're working with see the value in the data that are being collected. So similar to the fire monitoring, I think if the data are useful, then it usually goes quite well.
Awesome, that's really good to hear. So what kind of support then are you looking for from, say, the public, like people who are listening today? Is there anything they can do to either help push forward some of these technologies, or use today as like an awareness piece to share with other people? Yeah, are there any sort of action items for our audience today? So maybe starting with Prof. Adewati again.
Action items, I'm thinking if the technology could help people, for example, in Raja Musa, I wish that the project can help the females in the community. We were thinking of something, a social innovation in terms of the women in the area that could be involved in the collection of peatland groundwater level manually. And then if we could get them to be involved as well to correlate the data with our IT system. So that is something that I can say that is my dream on how to empower especially the female local community.
Awesome. That's such an interesting answer, Professor Adewati. And just to share, our team was just recently in Thailand, and we were actually speaking to the fire control station in the area. And quite interestingly, the fire chief himself was a man, but then all of his committee were all women. They had, I think, a whole committee of women. And I was curious, so I asked, what's the reason why, there's all these women, what are their roles, right? And he specifically said that, they are tasked with doing community engagement, because people are a lot less threatened, especially, when you're in rural communities, for women to come to your house and engage with you to, tell you more about peatlands, what to do for fire control management and all of that. So I thought that was an interesting role for women to play, like a very active role, in fact, in doing the communications and the outreach for a fire control station.
Right,
so that was cool. Yeah. Dr. Chris, thoughts from you?
Yeah, I think, I mean, as I said, this absolutely relies on having strong local partnerships. All of this work, we can't fly. After flying to Indonesia last week, I would do that every week, or in Malaysia. It's quite a way. So I think the more local partners we have who are happy or willing to work with us, the more we can do, and the more value the work will have as well, because it'll be delivering to local objectives and not just what we think might be useful from a long way away. So I think if you're interested in this, then please contact us. As Hanai said, we are somewhat constrained at the moment by supply chains, but there's a lot of interest in this. There is, we have some funding to try to build it up, and we would like to, ultimately build a network that connects with other network and has some value to the region. So that's, yeah, if you're interested, then please let us know.
Very cool. Thank you, Dr. Chris. Over to you, Hanai.
I guess there is much less, but yeah, I mean, that's one of the main things, having reliable partners, people interested in doing this. And, maybe something anecdotal is that as part of the projects we have been having in Southeast Asia, so we have a research assistant. He did his master thesis using some of the data collected, and then there is another PhD student in the University of Palangkaraya. So some of this data could also be used, for further education. If somebody's interested in, I want to write my master thesis, I want to write my undergraduate final year project, something like that, partners helping can also use this data for that specific project or research, in addition to having this large data set, from all the global peatlands. but yeah, we hope that the availability of Raspberry Pis will sometime next year. We don't know for sure, but yeah, in the meantime, we're working, improving the design, applying for research permits, signing memorandum of understandings. So, we are working behind the scenes. So once things are ready, we can help deploying or shipping some of the cameras to Raja Musa or to South Sumatra or Central Kalimantan, wherever we have partners or potential partners interested in implementing this. But yeah.
Thank you, Dr. Hone. Just to clarify, where are you planning on installing these cameras?
So we are mainly focused on the UK at the moment because it's quite challenging working in Indonesia. We need to apply for the research permit and everything is taking quite a lot of time. So foreign researchers are allowed in the country again to do research. We're working towards having this permit in place, and if everything goes okay, maybe sometime in October, November, we could install some of the first cameras in Kalimantan, probably Kalimantan next existing camera locations, and then maybe in West Kalimantan around Pontianak area, Tarantang or Teluk Pening areas, because that's where we have the actual partners. But it will depend on the research permit. If we have them in place, then we'll go to Southeast Asia. If we don't, then we might need to send them by courier, and then it will be up to the local partners to do the installs. And of course, we would be helping, but at the beginning, it's better to accompany them to give some assistance, and then they can troubleshoot them. They can be independent, and then we can just interact by WhatsApp.
Or potentially you could send them to Prof. Adwati and see if she can assist in that as well.
Yeah, that's interesting.
That would be cool. Yeah, it would be nice.
All right, we have one more question. I think we have time for one more question, which is in the chat box, specifically for Dr. Hone. Have you ever done research in Kalimantan West and Central Kalimantan? I think you mentioned you have, right? That's where you came from?
Yes. So in 2018, we got a research permit, or I got a research permit to work in Kalimantan. So we had study sites in West Kalimantan, 3 hours by boat from Pontianak, and then around Palangkaraya area, that was south and north of Palangkaraya. And we carry on some research for 2 years. After that, our research permit stopped, COVID started. And then we have also given some assistance to WRI as part of the PASSES project, and we helped them installing some cameras in South Sumatra. But my main research has been in Central Kalimantan and West Kalimantan.
Awesome. Thank you so much for sharing that. So I think that's all the time we have for today's Q&A session. But if anyone has any last words to share, words of wisdom to share with our audience, feel free, Prof. Adwati or Professor Chris.
Thank you, Mariam. I think people for Peat has done a very good job in promoting awareness for peatland forest. And I really hope that the audience, we can collaborate more. In fact, if Yone and Chris, if we could talk, over email or something about how we can further integrate our systems, that would be very interesting. So that's all, Mariam. Thank you.
Thank you so much, Professor Adwati. Chris?
Yeah, absolutely. It sounds great. I'm very keen to engage further with Dr. Adwati and anyone else who's interested. So yeah, and it's really nice to have this meeting because it's been a strange couple of years in terms of engagement. So it's nice to be talking to everybody. So thank you for the invitation to present.
Awesome. Thank you all so much. And it's nice that, we are kind of building different relationships and partnerships. So hopefully something does come out of it. So I'm really glad to have everyone here today. So with that, we can move on to just kind of closing off our session for today. Again, thank you so much to our speakers, Dr. Hone, Dr. Chris, as well as Professor Adwati. You have all been so great in sharing all of your research and your technologies with the audience. And thank you so much to our audience as well for your questions and your energy today. So much appreciated as people for Peat. So now I'm going to talk about our upcoming symposium. So as you guys know, this is part of our regional Peat symposium series. And this is our third symposium of the year where we focused on technology on Peat. And for the upcoming ones, we like to have different themes for each of our symposiums. So the upcoming one is going to be the role of youth in peatland awareness and haze mitigation, which will be a really interesting one because, there are countless opportunities for youth to get involved. And so we'll hopefully be speaking to some youth about what they've been doing on the ground to engage with people and to increase awareness on peatland conservation. So that's going to be happening about a month from now on the 13th of July. And in that same week, we will also have a workshop with the same theme about role of youth in peatland awareness and haze mitigation. I think we're specifically going to try and focus on activism. Yeah, so that will be a really cool one. And that's on the 15th of July. So please join that, especially if say you're a researcher and you're having trouble, okay, how do we engage better with the youth in our community? That will be a really good one to attend. And then our last symposium of the year will be about culture and sustenance, and that's happening in August. So do join us for that, and you all should be on our mailing list by now, so you'll find the invites for them then. So on to our next slide, which is, I just want to remind everyone that we currently have a People for Peat ASEAN Peatland Photo Contest. And that is also open to our speakers today, because I know you probably have a ton of photos of peatlands. And in each category, there's 5 prizes to be won. And the prize is 100 euros. So that's a nice chunk of change for anyone who's interested. And we've extended the deadline till, I think we've got a week. You've got 10 days to submit your photo contests. So we are doing DSLR photos, so professional level photos. We're doing mobile photos, so you don't have to have a fancy camera in order to apply to this contest. And then lastly, we're doing a visual storytelling, so multiple photos with just a short write-up about those. So please do join for that. I think it'll be really great, and we've already received a couple of really cool entries, so looking forward to it. So the next slide is so with all of our symposiums, as always, we really value your feedback. So we would like you to fill in our post-event survey, and the link is currently in the chat box, and you can fill that in. And once you fill that in, you will be receiving your e-certificate of participation. So please go ahead and do that and let us know what you think, what you liked, what you didn't like, and we will always take that feedback very kindly. So thank you so much. All right, I think that's it. Is there a next slide? No, that is it. So again, thank you so much to all of our speakers and our participants, and of course the team behind the scenes who make this event happen. So thank you so much for joining us and your energy today. We really appreciate it, and we hope to see you soon. Thank you.
Thank you.
Thank you. Bye.
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 Thank you.